Hey everyone, welcome to Chapter 11, Section 1. In this video, I'm going to go over problems regarding the areas of parallelograms and triangles. So at the top of the notes, I'm going to recap what it means to be a parallelogram. A parallelogram is any shape that has parallel bases and parallel sides. So think of a rectangle. The top and the bottom of a rectangle are the same length, and then the sides of a rectangle are different but same length. So a square is also considered a parallelogram. It just so happens that all four sides are the same thing. But there are other types of parallelograms than just rectangles and squares. So the area of a parallelogram is just base times height. And so for the height, you don't want to use one of these slanted edges if you're given a slanted parallelogram. If you have something like a rectangle, then you can use one of the sides of the rectangle. But if you have a slanted parallelogram, you're going to want to look for a perpendicular line drawn somewhere either inside or possibly on the outside. Sometimes you see a dotted line or dashed line drawn on the outside to make the right triangle. Either way, you would use that for the height because it's got to be perpendicular to one of the bases. Next is the area of a triangle formula. The area of a triangle formula is 1/2 base times height, or you could write it as base times height divided by 2. Same thing as the parallelogram. The height needs to be a perpendicular line. So if you have a right triangle, then one side will be the base and one side will be the height that form the right angle. But the base and the height are always perpendicular to one another. So if it's not a right triangle, look for a dashed line drawn inside or outside of the triangle indicating the height of it. So in these three examples here, I'm going to give you the area and then you're going to go work backwards and figure out the missing side. So in example A, I have a parallelogram and I have 17 feet going across at the base, and then the height is unknown. So it's just base times height. So 17 times something, 17 times x would equal 153. So just go backwards and divide. 153 divided by 17 gives me an answer of 9. So 9 feet is my height. On example B, it's a very similar problem. I know my base of 8. I do not know my height. And so I know my area is 148. So 8 times x would equal 148. So go backwards. 148 divided by 8 is 18.5. Part C, I'm giving you the area of a triangle now. It's 357 square inches. So you can see here I have a base of 34 inches and then I have an unknown height. So I'm going to set it up as 1/2 times base times height. So 1/2 times 34 times x. So all I did was I just multiplied 1/2 times 34. That's 17. So I get 17 times x equals 357. So now divide out the 17 and I get x equals 21 inches. So in my next two examples, I am going to find the perimeter and the area of the given parallelogram. So on part A here, I know my base of the parallelogram is 23 feet, and I know my height of the parallelogram is 24 feet, so that's enough information to figure out the area. I can just do base times height, or 23 times 24. So doing 23 times 24 just gets me an area of 552 square feet. Speaking of square feet, sometimes kids get confused on the units because they're like, you didn't square anything. Area units are always going to be squared. So inches squared, feet squared, meters squared, whatever. The reason why area units are squared is because you're taking a side and multiplying it by another side. So you're effectively doing side times side, so that's side squared. So you can just think of it like that. So when you're doing perimeter, your unit would just be like feet, inches, meters, whatever, because you're not multiplying anything. Perimeter is the sum of all the sides. That's still like one-dimensional. You're not multiplying anything together. And volume would be in cubic units, like centimeters cubed, because volume is a three-dimensional measurement multiplying like the base times the height times the length, for example. So you're multiplying three sides together, like on a cube or a rectangular prism. So just a little for your information kind of thing. turning my attention back to this, I do not know enough information to figure out the perimeter. All I know is this is 23, so then I can just kind of conclude that the top is 23 as well, but I do not know my sides. So I could put 23 here, and then I'm going to put an X here and an X there. And since I do know that the height is 24, and I know the distance right here is 7, this makes a right triangle. So when you have a right triangle and you know 2 of the 3 sides, you can use the Pythagorean theorem. The Pythagorean theorem states a squared plus b squared equals c squared. A and b are your 2 short legs of the triangle, and c is your hypotenuse of your triangle. And the hypotenuse is always opposite of the right angle. So the right angle will always point to the hypotenuse. So in other words, x will be the hypotenuse of this triangle. So I'm going to write 7 squared plus 24 squared equals x squared. So 7 squared would make 49, 24 squared would make 576. Add those two together and you get 625 equals x squared. All right, you need to solve for x and not x squared, which is why the last step is always take the square root. So the square root of 625 is 25. That means that this side length here, you can erase the x now and just write a 25 there. And so you're going to add together 23 plus 23, or that's basically doing 23 times 2. And then you're going to do 25 plus 25, or you're doing 25 times 2. You'll often see perimeter formulas say 2L plus 2W equals P. The 2's are because you have 2 of the same sides. Anyway, 23 times 2 is 46, 25 times 2 is 50, 50 plus 46 is 96. So you get a perimeter of 96 feet. So I'll put a capital P right here. So in example B, we're given the base of the parallelogram, 21, and we're given the side of the parallelogram, 17. We just don't know the height of the parallelogram. So what that means is we have enough information to calculate the perimeter because we know we have 2 sides of 17, and then we know we have 2 sides of 21, but we don't have enough information right now to calculate the area because we do not know the height of the parallelogram. So when you add it all up, you got 2 sides of 17 and 2 sides of 21, giving you a perimeter of 76 centimeters. Now, to find the height of the parallelogram, we're going to have to do the Pythagorean theorem again. We have a right triangle here, and so we know that 17 is our hypotenuse because the right angle is pointing at the 17. So 8's one of the legs and x will be one of the legs. So I'm going to set it up as x squared plus 8 squared equals 17 squared. So remember, when you're doing Pythagorean theorem, it doesn't matter which side is A or B. All that matters is which side is C. That has to be the hypotenuse, or the side that is opposite of the right angle. So 17 was that. So 8 squared is 64, 17 squared is 289. I minus 64 to the other side. 289 minus 64 is 225, and then you have to end it by taking the square root of both sides, giving you a height of 15. So with x being 15, you're just going to do for your area, take the base, which is 21, not 17. So you're going to do 21 times 15, which is 315 square centimeters, or centimeters squared. So in my next examples, we are going to find the perimeter and the area of each shaded triangle, adding a slight degree of difficulty here. So on this triangle, we have 19 as our base and 41 as just the leg of the triangle. I know that 19 is my base of the triangle because your base and your height are always perpendicular to one another. So I'm going to use 30 as my height, and then I'll use 19 as my base because 30 and then the 19 is the extension. If you were to like trace this triangle and make a large right triangle, then 19 is an extension of the base of the triangle. And if you use 19 for the height and 30 for the base, it's still the same thing, right? 30 times 19 is the same thing as 19 times 30. Just remember to do the 1/2 times it. So I hope I didn't over-explain it, because all you're doing is 1/2 times 19 times 30, and you can find your area. That'll give me an area of 285 square inches. Now for the perimeter, we're going to have to do Pythagorean Theorem again because we know 19 and 41, but we do not know this side here. But what we do know is that 27 and 30 are two legs of a right triangle. So this leg right here would be the hypotenuse of that triangle because it is opposite of the right angle. So really I'm just going to set it up as 27 squared plus 30 squared equals, we'll put an x here, so it'll equal x squared. So 27 squared is 729, 30 squared is 900, and x squared just stays the same. Add together 729 and 900, and that gets you 1629. What you need to do now is take the square root of both sides. 1629 unfortunately does not make a whole number when you square root it, so I'm going to round my answer to the nearest thousandths place. So when you type in the square root of 1629, you get 40.3608 and some other numbers that come after it. But if I'm rounding to the nearest thousandths place, I just need to look at that fourth decimal place to see if it'll round that third decimal place up. So if this is 5 or bigger, it'll round it up. So since it's an 8, that'll round that 0 up to a 1, giving me an answer of 40.361, approximately. So now we know our missing side is 40.361, so add together your other two sides, 19 and 41, and that'll add up to get 100.361 inches, and that's my perimeter. So on my final example here, I'm actually going to have to do the Pythagorean Theorem twice, and that's because I only know one side of my shaded triangle. That's 29. I do not know the height of this triangle, and I do not know the hypotenuse of the triangle. So I'll start by looking at this little triangle with the dashed pinkish red lines, and I have two of the sides, 13 and 6, and I don't know the third side, x, and so 13 is the hypotenuse because it's opposite of that right angle. So I'm going to do 6 squared plus x squared, or x squared plus 6 squared, doesn't really matter, equals 13 squared. So 6 squared is 36, 13 squared is 169, and so all you have to do now is minus the 36 to the other side, and then square root the difference. So 169 minus 36 is 133, and so we're going to square root both sides. And the square root of 133 is not a perfect number, so you have two options. You can say x equals the square root of 133, which is what I prefer, frankly, or you could round it and say that x is about 11.533. But I strongly encourage you to keep it in the square root form because we're going to keep using that number. So the square root of 133 written like that is actually an exact number, whereas this is an approximation. That's why I use the squiggly sign. So I'm going to use square root of 133 from here on out, but I did just want to point out that it is approximately 11.533. So we know x is the square root of 133, and so now we know two sides of our triangle. We just don't know the hypotenuse. But this is the base and this is the height of that triangle because the base and the height are perpendicular to one another, and we're given the right angle right there. So we have enough information to do the area right now. So I'm going to go 1/2 times 29 times the square root of 133. So typing all this into my calculator gives me an approximate area of 167.222 centimeters squared. So now we just need to find our perimeter. So I'm going to call this side y, and we're going to do the Pythagorean Theorem again. We're going to go the square root of 133 squared plus 29 squared equals y squared, because y is our hypotenuse. It's opposite of that right angle. So the nice thing about leaving it as the square root of 133 rather than rounding it is you get an exact answer when you square it. When you square a square root, you just get that number that was inside the square root. So the square root of 133 squared is just 133. And now we just have to square 29 and equal it to y squared. And 29 squared is 841. So add these two numbers together, and that's going to equal y squared. So we finish this off by square rooting both sides. And so y is going to equal the square root of 974. It's not going to make a perfect number. So you could round it if you wanted to. But like I did with the 133, I want to keep it in the square root if I can. But the square root of 974 is approximately 31.209. And so here's another reason why I like to keep these in the square root form rather than just rounding it. The perimeter is the sum of all the sides, right? So if I add together two rounded sides, my answer is a little less accurate than just typing this into a calculator plus this into a calculator plus 29 into a calculator and just rounding my final answer rather than typing in two rounded numbers. So I'm going to use the square root of 974 for my y, and I'll just type these three numbers added together in my calculator and get the answer. So I get a final answer of about 71.742 centimeters. And so that's going to conclude these notes. Thank you for watching. Hope you learned something, and goodbye.